Okay, good afternoon or good day, whatever it is, the time you are trying to watch this. Today, we want to consider what we call circle theorems. So, what this means is that we want to try to examine what are the basic theorems that have to do with a circle. And I would like you to give attention to every details that we're going to talk about this afternoon or this day. However, we're going to start with something. This is a circle. Please don't mind the way I've drawn my circle. Now, this is the center. It's called the center. The line drawn from the center to touch this is called what? Could you think of that? And it is called the radius. There is another part of it that comes from a part of the circumference to another part of the circumference without passing through the center of the circle. We call that a chord. Now, when you call that a chord, this part, the inside part here, this inside, let me shade it for you to see. This inside part is what we refer to as a segment. So also is this. So they are referred to as a segment, and we have two kinds of segments. We have what we call the minor. We have what we call the minor segment, while the other one will be called, we'll call that the major segment. Also, the part of the circumference, this part of the circumference is what we call the arc. The arc. You see, the part of the circumference is the arc, while the circle in the inner part of the circle is what we call the segment. So if this is the minor segment, this will also be known as the minor arc. Very good. Also, we also have a part of a circle that will come from a point of the circumference to another point of the circumference, passing through the center. You can see that from one part of the circumference to another part of the circumference, but this time around it is passing through the center, and this is what we refer to as the diameter of a circle. Now, think of it. What is the relationship between radius and diameter? So diameter is always the 2 times the radius. Good. Now, there are also two things we need to quickly look at under the circle part as well. Now, this is a circle, center O. The line drawn from here to here, if I label it as B, is called a radius. From here to here is another radius. Now, the cut out portion of that radius, the part that is being cut out, this part that is being cut out that I'm shading right now, this part you're seeing that I'm shading right now is called what? Think of what you think is going to be the answer. Pause and play. And this part is what we refer to as a sector, the sector of a circle. So the way we have a minor segment, minor arc, major segment, major arc, is also the same way we're going to have a minor sector and a major sector. And these are the basic parts of a circle. But today, we want to actually consider the circle theorems itself. And we're going to, in this lesson, we're going to quickly look at 3 theorems as much as possible. And we have the first theorem, which we call theorem 1, says angle in a semicircle. Angle in a semicircle is 90 degrees. That is, the angle inside the semicircle is 90 degrees. What does that mean? Now, if I have a circle and I have a center, the first thing that should come to your mind as a keyword there is, what is a semicircle? And you know that semicircle is half of a circle. So that tells us that if I have here as the diameter labeled as A and B, and I join the 2 points A and B to give me a point C, the angle formed by the diameter is always 90 degrees. The angle formed by the diameter is always 90 degrees. Take notes. And that is what the theorem is saying, that the angle formed by the line, the diameter, is what we refer to as 90 degrees. 90 degrees. Please take note of that. We're going to take 1 or 2 questions very quickly for us to see how that would always run. So I have a very fantastic kind of questions here. So I'm going to take this very quickly. And if you examine this question, let me reduce the font so that it's smaller and we don't waste too much space. Good. Now, you will agree with me that this is a diameter. This is the diameter. So if this is diameter, the angle facing this diameter is obviously what? 90 degrees. So what will be our result? So that means that 65 plus 90 plus x is equal to 180 degrees, which means angles in a triangle. 65 plus 90 is 155 plus x equals 180, and x equals 180 negative 155, and my x will give me what? 25 degrees. It's as simple as that. That is one of the major theorems we will be considering under this topic. Okay, let me take something a bit complex, but not so complex though. So we're going to have something like this. Very easy though. If you can concentrate, then you will agree with me that it is really easy as well. Okay, so let's look at this question. Now, I want you to take time for like 2 minutes, go through it. You may pause the video, and after 2 minutes, whatever you've been able to try, you can start the video again to see maybe you're right or you're wrong. But what I'm going to look out for is, yes, I can see that this is a diameter. It is obvious that this is diameter. And if this is a diameter, it means this whole angle here is going to be 90. However, something is staring at us here. And what is that thing? That this line that I marked blue is the same as this line that I've marked blue. Why? Because this line is a radius, this line is a radius. And don't forget that in every circle, the value of radius A is the same thing as the value of radius B, same as the value of radius C, and like that. So, which means that this triangle will form an isosceles triangle. That's the implication. So, looking at it critically, since these two sides are equal, it means the angles will also be equal. And I can say y is equal to 55, which I could term as base angles of an isosceles triangle. Base angles of an isosceles triangle. So I know here to be 55. To get my x becomes easier. Why? Because I can say x plus 55 plus the second 55 is equal to 180 degrees. And what is the reason? The reason is because angles in a triangle, or rather can we say sum of angles in a triangle. So that means x plus 110 is equal to 180, which means x equals 180 minus 110, and x is equals to what? 70 degrees. So I also know this angle here to be 70 degrees. Now I'm left with z. What do I do to get my z? All I need to do to get my z is to say x plus z is 180 degrees, and that is sum of angles on a straight line. So which means that 70 plus z equals 180, and z equals 180 minus 70, and z equals to what? 110. Good. If you find it difficult, you can watch the video again. Now, I'm going to share a few questions with you later for you to try. However, I'm going to put in a few questions for you to just play around before we go into the next theorem. Before we go into the next theorem, I would like you to just play around a few number of questions that I'm going to pull up right now. All right. One second, please. Okay, you can try this couple of questions, and trust me, you will find them very, very interesting. Okay, so we're going to move to another theorem. And this theorem states that angle at the center is twice angle at the circumference. That the angle at the center is 2 times the angle at the circumference. Now, I need you to please listen carefully here. Now, you might have learned this topic in a different way. Any way you would have learned it is correct. You could just pick the best one that suits you, because my explanation may be quite different from what you're used to. Now, this is a radius. This is another radius. Now, the question I want to throw at you is this. This new line I'm drawing, is this a radius? If it is a radius, if to you it is a radius, tell us why. If to you it is not a radius, tell us why it is not a radius and what is the name of that line. So to me, these two lines are known to be chord of a circle. Good. Now, the chords, where the two chords meet, is what we refer to as the angle at the circumference. Where the two chords meet is known as angle at the circumference. Please take note. Now, how do I also another way you can know what angle at the circumference is the lines where the angle joined by the lines that have nothing to do with the radius or the center. If you look at these two lines, they have nothing to do with the center of the circle. Good. Now, how do I get the radius of the angle at the center? Now, what I do is this. From the angle at circumference you have gotten, just trace it through the center and let it hang here. Now, don't forget that there are always two angles at the center. There is the interior angle and there's the reflex angle. The one closer to the hanging point is always the angle at the center. The one closer to the hanging point is what? The angle at the center. So if I draw the line from this place now and it stops here, this interior angle is closer to this dot than this exterior angle. So this becomes the angle at the center. So if I label here as O, I label here as B, I label here as C, B, and I label here as C. So it means that the angle at the center, which is AOB, will be 2 times the angle at the circumference, which is angle ACB. The other part of this theorem is when you have it this way. Now, this is center O, this is A, this is B, this is C. This OA and OB are radii. Definitely the angle that has nothing to do with the center is this angle here, which automatically becomes the angle at what? Angle at the circumference. Now, just like I explained the other time, how do I get the angle at the center? So from this angle at the circumference, can I draw a line passing through the center and stops here? Don't forget there will always be two angles, the interior angle and the reflex angle. So which of the two angles is closer to this point you're seeing here? You will agree with me that it is the reflex angle. So that is the angle at the center. So that means reflex angle AOB, its angle at the center is 2 times the angle at the circumference. Now let me quickly recap it again. The theorem says that angle at the center is 2 times angle at the circumference. And what that tells you is that when you have a circle like this, every circle must have a center. Now this is the center O. You can see there's the center O. Now you have from A to C as the chord, from B to C also as a chord. Now where the two chords meet is known as the angle at the circumference. You can see this is a chord, this is another chord meeting here, and that becomes what we know as the angle at the circumference. Now, I now said you will draw a line from that angle passing through the center. You draw a line from that angle, ensuring that it passes through the center and hangs somewhere here. For you to determine where will be the angle at the center, any of the two angles at the center closer to that point is your result. And we agree that it is the angle inside here. And that's why we have angle AOB is 2 times angle ACB. Similarly, we said if we have the diagram to be in this form, now this is also a radius, this is another radius. However, this is a chord, this is a chord. Where the two chords meet becomes the angle at the circumference. Then from there we draw another line passing through the center, stops here. So which of the two angles at the center is closer? Will it be the interior or the reflex? Then you see that the reflex is closer than the interior. The reflex is closer. And that's why we say reflex AOB is equals to 2 times angle ACB. By the time you practice a lot of questions, you will really get used to the the way it works. So I'm going to solve about 4 examples here. I'm going to solve about 4 different examples for you to be able to see how it works. And I'm sure you will be fine with at least these 2 theorems that we're trying to discuss this afternoon. Sorry, please, just trying to. Okay, good. So quickly, please, I need to go back again and get a few questions. One second, please. So I won't do everything. I'll just pick a couple. Maybe I'll do like A, and I will do F. Then I'll look for another kind of questions again that I'm going to do. So look at your A critically. This is the angle at the circumference. So if you draw, it stops here, X is closer. So X is the angle at the center, which is 2 times the angle at the circumference, which is 51. And your X is what? 102. For F, this is the angle at the circumference. If you trace it, it stops here. 195 is the angle at the center. So 194 is the angle at the center, which is 2 times the angle at the circumference, which is X. And that's 194 is equals to 2x. So over 2 over 2. 2 cancels out 2, and my x is what? 97 degrees. So you can play around with the remaining questions there. However, we have some advanced kind of questions that I would like us to as well touch. Oh, fantastic. Fantastic. So I will do these 3 questions, and that will be all for this particular lesson. Okay, so let's start with M. The angle at the circumference is 110. Let's confirm what will be the angle at the center. So the angle at the center should be this. Good. Which is A. So that's for question M. So that's A is 2 times 110, which is 220. Please note, X is not the angle at the center. A is the angle at the center for this particular circumference, because the circumference is here, and if you trace that line and it stops here, the reflex is closer. If you go back to when I was explaining the theorem, you can see when the diagram is within a semicircle, the reflex is usually the angle at the center. If you're confused, you can go back to the example, or you play back to my explanation for you to see that clearly. So what will be my x now? Obviously, my x will be 360 minus 220, because I have the sum of angles at a point, and that makes my x to be 140. For this question, before I can do anything, this is already an exterior angle, so I need to find what is inside here by doing angle on a straight line. So let me say here is A. So that means A plus 142 is equal to 180. That's angles on a straight line. So which means that A is 180 minus 142, and A equals 38. Now this becomes the angle at the center. So let us determine the results. If we trace it down, x automatically becomes the angle at the center. So that means angle at the center is 2 times angle at the circumference, and that makes x to be what? 76 degrees. I hope it is very clear. Good. Then the last question. Now this is the angle, this is an exterior angle, but we're given the angle at the center. So let's automatically, this is an angle at the circumference. If you trace this down, 136 is the angle at the center. So that means 136, which is angle at the center, is 2 times angle at the circumference A. And that means 136 is equals to 2A over 2 over 2. 2 cancels out 2, and A is equals to 68. So what will be my x? X will now be 180 minus 68 from angles on a straight line, and that will give us 112. Good. Now, it's possible for you to understand this video straight away from the beginning, and if you think you're confused, you could just play back and watch the video again. So these are the first 2 theorems we're going to be considering under circle theorem. So I will be sharing with you another 2 theorems in my next video. Thank you very much, and do have a wonderful day.